Internet Report, where we uncover what's working and what's breaking on the internet and why. This week, I'm joined by my colleague, Mike Hicks. He's coming to us from Perth, Australia. So welcome, Mike.
Thanks very much. It's great to be here.
So on this episode, we're going to talk a lot about SatComms. And we also have a great guest on the show that Mike interviewed, and that's going to be really interesting to listen to, so make sure you stay tuned for that. But first up, we wanted to address some of the major headlines, and one of them had to do with TikTok and the US government's announcement that they were effectively going to remove financial incentives for TikTok to continue to operate in the US, because it's going to, in 45 days, ban financial transactions between TikTok's parent company, ByteDance, and US citizens. So when that does take effect, that's really going to remove any reason for them to continue to operate. So while it's not outright banning them, but they're, because they're not going to be able to, for example, have any transactions where they're paid for advertising, for example, from US companies, then there really wouldn't be any reason for them to continue to stay here.
Yeah, they're not in it for the good of the people, essentially.
That's right. But let's say, for the sake of argument, that the application itself or the service itself was banned. In terms of how the US government would do that, we can look at other instances in which, for example, a website or an application maybe is infringing on the trademarking or intellectual property, or it's been found to have illegal content on it, or there's fraud involved. There are a number of things that the authorities can do in the US in order to shut down a site. One of the things they can do is they can go to the DNS registrar, or the domain registrar for the domain, like in this case TikTok, and basically say, like, hey, you need to revoke that domain. Or they could go to their US vendors, like their CDN provider, or whoever's hosting them, or their DNS hosting provider, like Akamai, for example, serves their content, and go about it that way. There really wouldn't be an incentive to do it from a network standpoint.
Everything's technically feasible, but it becomes how much effort you put into to achieve that. So
Right, exactly. And even say, like, if they really wanted to go rogue and they wanted to serve the application outside of the US, and US users wanted to go and access the application, if they have to, especially because we're talking about video, if they're not connecting, if US users are not connecting to the application in the US, so they're going, like, let's say, to Europe or to, another part of the world to connect to the application, then their performance isn't going to be very good. So it's not going to be a very enjoyable experience. And for that reason, again, you're probably not going to need to take any further action in order to prevent US users from using the service.
Yeah, exactly. It's got to be that user experience, and there was, in the early days, everybody started setting up these little servers on oil rigs and independent domains, but you lose that whole CDN aspect.
Right.
Everything's not close. So I'm making these huge journeys. So everything looks like I'm in Perth trying to get out to get some sort of decent network connectivity. So it becomes not worth it. Exactly right.
Exactly. And preventing users from reaching a particular service, like, for example, what they do in China. There are basically 3 major service providers in China, and heavily regulated versus, thousands in the United States. And, they all have their own ways of operating their network. So while it's technically theoretical to do things like IP address blacklisting or intercepting DNS queries, it's not foolproof, and it's not really feasible or practical at the scale that would be required and would be overkill.
Yeah, exactly. And ultimately, it all comes back to the main thing: take away the revenue source, all that becomes unnecessary.
Exactly. All right. Okay. So kind of moving past kind of the technical possibilities or feasibility of a band like this, we were talking a few weeks ago about the SpaceX's Starlink supposedly low latency, low orbit satellite system that is currently wanting to bid for the FCC's high speed kind of rural connectivity project that they have going on in the US.
Yeah.
And you had talked to someone who had previously, he's been in the networking industry for over 20 years, and you worked with him in SatComms at the European Space Agency.
Yeah, that's right. Yeah, Ray Hunter was talking to that. So we're having this conversation, and we covered a lot of this there. But one of the things that came out was that we were talking specifically about the Starlink stuff and the low latency aspect. And you know, it's totally feasible to do this. You know, everybody can have a low latency link. We can do it between point A and point B very quick. We can have small packets. We can get this fast lead there. But one of the points Ray brought up was that's irrelevant. Everything you talk about from low latency has got to come from the application, ultimately the end user experience. So it starts to get into all those aspects. So it's yeah, it's kind of interesting. And there's other things that start to impact us as well on when we start to get into this wireless and these SatComms, whether it be geostationary, whether it be microwave links, you know, which is a form of that type of connectivity. And we're starting to have other outside influences. So whereas, you know, we're dealing with an ISP, a backhoe can dig up a fiber link and cut that connection across from there. It is extreme. It does happen, but it's extreme there. Whereas we're impacted by things like the weather when we start talking about the satellite situations and the environment, the sea and whatever takes in place there. So.
Exactly. And I know you guys are going to get into a little bit like the differences between traditional satellites and kind of the Starlink constellation satellites and how it's different in terms of, you know, your relationship to the satellite itself. But one of the things that we were looking at earlier was an example where there was satellite connectivity between two stations over a body of water. So there was a body of water between them, and just how weather sensitive this method of transport is, because we could see that there was significant attenuation of the signal on like this regular basis. So it was something like every 7 hours because of like the tide going in and out. So there's, you know, we kind of look here, we can see, for example, you had this instance here where, so on the 2 points on the far left and the far right are basically where the satellite kind of stations were, right? So the satellite dish, is that right?
Yeah, that's right. Yeah, the two endpoints across from there. You know, this just to get to that, there's a, you know, there's a reason, and we have to do this situation because there's no other way to get there. There's no submarine cables. There's no other way. So you know, it's actually not a long distance. It seems ridiculous to send it up into the air and back again. But it's just the only way to actually achieve that connectivity. So yeah, it's two essentially ground stations at either end of a connection.
And so then, you know, what we're seeing here is that kind of on the top, there's like this, you know, you can see kind of like these little pyramids here, and they're sort of representative of these, and they're spaced, you know, kind of, you know, the same length of time apart. And we'll get like this kind of 9% packet loss on the regular, and then it will just go away. So, you know, exactly.
And you can tie those directly in with the tidal patterns. And there's other aspects that come in, because this is effectively, or is coming across the body of water. And as you mentioned, the attenuation pulls down. It has this impact on the radio waves, which is essentially what we're talking about here. And then, you know, this, even if we start to get choppy water, it can start to change these sorts of things. So you can have different patterns that come across from there. And so you could lose signal during the winter months where the weather is really choppy. You've got a sort of 2 meter swell occurring, could start to have a dramatic impact across from these. So what they do in those instances there, you see, you've got this irregular pattern, you can predict around it. So you just build the applications to sort that. you effectively start to have almost a little CDN where a lot of the information sits on site, and we just go out for updates. And you can sort of shift those patterns. So the application is suited to meet the network's requirements across from there, which is a lot of what Ray talks about when we start to get into the satellite communications.
Yeah, absolutely. It's really kind of down to the application provider to tune their application in such a way so that it's optimized for transport over something like SatComms, for example. So, and so exactly. Not really something that's necessarily controllable by the operator of the satellites themselves. No. So that's an interesting bit about it, because, you know, of course, like, you can claim low latency, but from the standpoint of how is the application performing, to a large degree, that might be somewhat out of your control, unless you're, of course, working with application providers, and they're incentivized to optimize their application to go over this type of communication network.
Yeah. So, exactly. I mean, what you have to do is, whereas this may be part of my communications, so I need to understand what could be the characteristics of this, and then, exactly as you say, adapt my application to suit that. Because ultimately, as much as we want to love to think as the network is the key part, the end user experience is the one that's going to be the key driver in all of this. And you're exactly right. The incentive, it's incentivized to actually use that from an application delivery point of view. What's in it for me to deliver that?
That's right. So why don't you tell us what's up next with your interview with Ray?
Yeah, thanks. So, so I sat down with Ray Hunter. Ray Hunter's been in is a network solutions consultant at Globis, based out of the Netherlands. He's got over 20 years experience in sort of networking stuff. And as Angelique mentioned, I worked with him at the European Space Agency, where we played around with a lot of SatComms to try and optimize deliver the application to control things like sort of payloads on the shuttles, as well as delivering applications to scientists around the world that come across from there. So very interesting chap. Both English natives, so you might actually need subtitles underneath, but no, it's very good.
Great. Yeah. Okay. Well, let's take a listen.
Well, I'm joined today by Ray Hunter. Ray is a network consultant with Globis, and he's got sort of a lot of experience in terms of building networks, and then specifically in looking at sort of SatComms. So really want to talk to you today, Ray, about the SatComms, some of the new emerging technologies, and just really to understand how they're going to fit in terms of delivering applications.
Oh, hello.
So let's start off. So satellite networks really come in all sort of manner and shapes and sizes. There's a multitude of techniques and technologies used to transmit the information. What do you consider a major driver for their usage?
Up until now, the SatComms have been relatively limited in niche cases where we haven't had any coverage from traditional wired or wireless internet services. And the go-to model we've had has been to use a secure overlay over an insecure underlay transport network. So we would be using standard internet over copper or over fiber, and then the SatCom area would be used for the niche case where there wasn't any coverage at all. But due to new technologies such as SD-WAN, there's the opportunity to combine these insecure links and these variable availability links in a manner that allows you to create an end-to-end solution for the path that's more reliable than the individual links themselves. So I think that's where we're going to go, is smart path selection is going to help us to combine a lot of this technology into a single solution.
So where we're talking about these hard to reach places, we're talking really geographically dispersed, or is this something? Is it a competing technology of like a 4 or 5G type of aspect, or is it really there is no coverage there, and this is the only way to get data in from a SatComms perspective?
I think it's very dependent on the actual geography we're talking about, because in some areas there just isn't any 4G or 5G.
Yeah. And
we're also seeing that from the political perspective, there's actually some consumer pushback for 5G, because as you know, the higher frequency you use in the radio, the lower the reach, so you actually need more towers for similar coverage. And there is pushback from not in my backyard for the
Yeah.
amount of towers that are getting deployed. So there is opportunity there, as depending on how the pricing and the availability of these competing technologies roll out for other solutions. The traditional would be where you have a very diverse population, where it's actually too expensive to roll out the number of towers required to cover 4G or 5G.
Yeah.
If you look at the United States compared to Europe, in Europe you have very, very dense coverage for Wi-Fi and also for 3G, 4G and 5G coming up, whereas the pricing of these technologies in the US is really an order of magnitude higher for cellular.
Yeah, okay. So price obviously becomes a consideration from there, as well as the coverage type of stuff. If we're talking around sort of some of the new systems, we say the satellites, we touched on sort of the LEO stuff, the low Earth orbital satellites around from there. Do they give any benefits over that we would have from a traditional, when we're thinking back in time, sort of when you and I were talking, there was a lot of geostationary types of satellites. Now we're starting to see these distribution of a low Earth orbital stuff, the LEO stuff from there. Is there a difference in either perception of those systems or the expected outcome from those?
You're definitely battling a perception issue from history, in that in the geostationary situation, you had two very big problems. Was the latency, because the satellites are physically far away and the speed of light restrictions meant you had a fixed latency. And the other one was asymmetry, was that because of the way the bandwidths were licensed and the size of dish you were allowed to deploy, the bandwidth in one direction was very different to the bandwidth available in the other direction. Yeah. And that limited their use in some applications, because it assumed that you were broadcasting data from a central point to multiple endpoints, whereas a lot of people are actually working precisely the other way on. They have very dispersed sources of data like telemetry that they want to concentrate in a central area. And the other thing about the geostationary, of course, is that you've only got one satellite typically, and when you hit the equinox, the sun goes in front of that that dish, and you lose your connection for several minutes. And I've certainly come across that situation on an oil platform where someone starts shouting at you to say, fix the link. You say, give me 10 minutes. You come back and the link's working okay, and you're a genius because you fixed it, because the sun's moved.
That's excellent. So, I mean, just to qualify that, I guess the geostationaries, they sit around 35,000 kilometers, and then low Earth orbital is sitting around, anything from 200 to 1,200 kilometers.
Yeah, and that's a huge difference in terms of the speed of light.
Yeah, absolutely. And then the other difference, as you said, the fact from a geostation, we're looking at a single satellite that goes with the Earth's orbit, and then the LEO stuff is a constellation. So we got lots of little. They're probably all the same size. We have a mesh of satellites around from there, but they essentially stay in place, and then the Earth turns, and then we do handoffs between each one.
Yeah, and that's another good point to say, is that the latency for LEO is understood in that it's going to be a lot less. So the path may be shorter, but I don't think what's very well understood is how the handoff's going to work when you've got multiple satellites in view, or where the constellations are incomplete because these guys are still launching their constellations, and or where users are located at high latitudes where the satellites may not pass as frequently overhead.
Right, okay. Are they going to be impacted by sort of weather conditions? Obviously, there's space weather and whatever up from those and that impacts it. What about sort of down on a terra firma type of position? Is there sort of considerations around as well?
Oh, certainly. I mean, I've come across simple microwave links where it rains and the path bends, and the microwave link no longer works over a very long hop. And you have similar at these frequencies, you have similar effects. I've also worked on systems that rely on the weather using tropospheric scatter to bend the radio waves through clouds. Right. So this absolutely has an effect. And similarly, you have very, very physical effects, that someone puts a crane in front of your dish and well, of course, with fiber, someone can dig up your fiber, but you also have line of sight issues as well with dishes.
Yeah, that's it. I had a similar one with a microwave. It was a tidal basin, and it was as the tide dropped, it dragged the signal down. So yeah,
Right,
fully understand that. So yeah, interesting.
Mm-hmm.
So we've got obviously these idiosyncrasies or these conditions that we have to take in terms of the actual satellite delivery itself. But there's obviously things you can do to tune that from a delivery perspective. What would you recommend, or what do you think, or when you're tackling a satellite network or a network that includes satellite coverage, what do you do in terms of tuning that from a performance perspective, to get the most out of it? We obviously have fixed things such as the latency, or in some like the LEO, unknown latency, but is there anything else you can do or recommend when you start to tune this from a delivery perspective?
I think you have to look very much at the data you're transmitting.
Mm-hmm.
So there's definitely potential for exploiting synergies with upcoming technologies like SD-WAN, where the technology points between a number of differing paths with differing statistics, and then it chooses the correct path for that particular piece of data based on how the links are behaving at that moment. So in traditional routing networks, you either had the link was up or the link was down, and then you routed based on that situation in the network. Now we're looking much more at how the path is selected based on the needs of the data itself. So you've got upcoming solutions like Shim6, which combines a number of IPv6 connections to the together to form a tunnel. And you have other situations like MIPv6, where the programmer, instead of having to worry about all the individual links, just talks to the tunnel. But I think there's a lot of scope for improvement and new technology there, because the programmers themselves are not used to dealing with this complexity. Programmers generally deal with a socket interface, which hasn't changed for many, many years, and that does not yet reflect these new technologies of the underlying links. Mm-hmm. And also the programmers themselves are just not used to dealing with the problems that are below. So even WAN optimizers that can do things like local TCP ACK and have application aware handoff to avoid the latency issues, I think there's still a lot of development to be done there.
So it's a combination we're looking at. So we're saying the developers essentially are looking at, they just consider the next hop to be their NIC, the interface coming out from the server or the application from that perspective. But if they can combine that intelligence with stuff we've got, you mentioned the mobile IPv6 and the Shim stuff as well. Those are obviously intelligence or intelligence within the network itself. So you're saying it's a combination of the two to give the best delivery mechanism.
Yes, and there's a very much an ongoing debate of whether we need an intelligent network or whether we need intelligent end devices. So the experience of the intelligent network has been very much colored, if you like, by the experience of X25 and those sorts of technologies from the past, which were incredibly reliable. You put your packet in there and it came out at the other end, and no questions asked, but the price wasn't right. And now we have a shift more towards with the experience of mobile phones, whereby the network is considered dumb and the end device has all of these different radios available to it. It has wireless, sometimes wired. It has 3G, 4G, 5G, whatever you want, potentially satellite as well in the future. And then the device itself has to work out the path. And I think we're going to come to some sort of middle ground where there will be some technologies emerge that allow the network to provide some smart solutions, but there will also be some requirement on the end devices themselves for path selection.
Cool, that's interesting. So this combination, like you say, you don't think about it with a mobile phone, but you can walk from one area to another. It just picks a handoff up and changes. If I'm in the office here or the house, it switches to the Wi-Fi. If I go outside, it picks up 4G and seamlessly without me knowing. So, but it's a combination. You're saying you see that in the future.
Absolutely, and it's very application dependent, because to be honest, if my mobile phone doesn't work overnight for 8 hours and no one's trying to call me, it's not a problem. But if it drops for 1 second and my call drops when I'm on a sales call to a really important person, then I care about that. Yeah. So it's going to be very application dependent of what we're trying to solve in terms of the solution we deploy will be very linked to the use case that we're trying to solve at the end of the day.
Yeah, that's interesting. So that kind of brings us back, I guess, to the satellites, because a lot of these new vendors who are starting to push the LEO stuff out there, and they're, from a marketing perspective, they're talking about low latency. Essentially what you're saying there is that latency isn't the thing. And it is a thing, it's very important, but it's going to depend on the application, the use case, and what it is we want to achieve as a user.
Absolutely, and they're marketing this latency because that's something they can do compared to geostationary, and they've got to win that battle of perception, as we stated earlier, that they need to remove this idea that SatComms is high latency. So I can understand why they're doing that, but it's not, from a user perspective, it's not the be all and the end all.
Yeah, absolutely. So essentially what we're saying is we've got to work with every technology. We've got to be able to do what's best for my location on top of my application and what it is I want to achieve. Like you said, I'm talking to a CEO. I need my call to go through from talking to you and me chatting. It doesn't really matter so much. So yeah, okay. So that's very interesting. Well,
and that will also change over time because the devices have become much more mobile. And it used to be that devices were just plugged in the wall and that was it. But now the mobile device is moving with you all over the place. We've got wearable tech coming up. We've got internet things which are placed in vineyards to monitor crops. So the internet really is exploding and developing at this time. It's certainly a very dynamic time in the industry.
Yeah, and then on top of that, I guess, then those, back to you about the intelligent path selection aspect, those are going to be dynamic and changing all the time, depending on what's going on. So it's important to understand those paths through there. And then, does the characteristics match this? So yeah, I can see this need for this merging of minds, as it were, the intelligence in the application or the end device combined with my network to do almost intent-based networking to understand what's happening and deliver it down a correct path.
Yeah, absolutely.
Cool. Well, thanks very much, Ray. That's been really interesting. It's great to talk to you, and yeah, thanks very much for your time.
Yeah, you're welcome.
That was a great interview. Really interesting topic. What stood out to you in terms of, having had a chance to kind of reflect back on your discussion with him? Was there anything that we didn't discuss earlier that was either surprising to you or you thought was particularly interesting?
Yeah, I thought what was an interesting point was this. If we go back to the history of the satellites, they were put in because that was all we could get connectivity to. In fact, when I first came to Australia, the only way I could actually get connectivity into my house was for a satellite connectivity. But we sort of changed that over the age, and they kind of not dropped out of fashion, but they stayed around there. But with the advancement of these low Earth orbital stuff, we're starting to see this change now, where it's becoming, yes, it's the best option for bang for buck, but it is also changing the usage of the satellites. Where once they were expensive and they were, that's the last resort, they're now starting to be thought of more and more. And if you take that rural type of scenario where we've got, you mentioned around the SEC funding aspect from there, there's no need to actually go and put sort of a whole bunch of 5G towers up there. It becomes cost prohibitive. So this the LEO stuff becomes really useful. But it also then becomes that we start to consider things like the Internet of Things and this mobile connectivity. This is the best way to connect these systems up. So I guess an interesting point for me was it's moving into mainstream, and the application owners themselves, and as well as the onus on them to deliver over it, have to be aware that these are going to be part of their delivery system, and have to understand the characteristics of how the applications are going to perform across those types of links, because it may well be their last mile solution they need to satisfy, and as we said, meet that end user experience. Yeah,
no, that's a really great point. So maybe something they need to get ahead of now.
Absolutely.
All right, well, that's our show. Thanks for joining us this week, Mike. Don't forget to subscribe, and for those of you who do subscribe, we have a free t-shirt that you can pick up. Just simply send a note to internetreport@ThousandEyes.com, and you can also drop in comments or suggestions or questions to that email address as well. So take care, and you can also find us and some of the videos from our event that we had a couple weeks ago at our YouTube channel. So until next week, have a great week.
Thanks very much.